much the properties that they have. And remember stopping on this slide showing the ones that we have at case, okay? So I know that you used some of them, right? So the mounting plaster and the snapstone are the ones that you use the most. But you use like the silk rock sometimes when you want to pour like your final impressions, okay? Usually when we send to the lab, you're going to pour your impressions based on this kind of stone, okay? And the type 3 you can also use, but like kind of harder stone as well. It's not so precise, but also works well for diagnostic purposes. Okay. Okay. Just going back a little bit on the material that you're covering. Don't forget that for your final test, that lecture that I gave on detail for amalgam will be on the test as well. Okay. I know that we talked about that last time. Meaning that on the following week, we are going to start at 8:30, okay, just to catch up with everything, since I stopped the lecture a little bit earlier last week, the week before. We're going to cover the final of the impression materials lecture that I will try to start today. And I'm adding a lecture about glass ionomer cements, okay, that you still don't have on Canvas. We'll try to upload by the end of this week. So it's kind of an additional lecture that I created for this year, okay? So I'm going to send like an article that I wrote kind of a few years ago, and we're going to have a lecture about it, okay? Perfect. Okay. So I think you used alginate at some point on one of the courses, right? So how did you manipulate that? Was only manual, right? Speculation, so you just mix the water with the powder, right? Okay. How about the casts? When you pour the cast, which one you used? Do you remember? Was the microstone or was the microstone? Okay. Okay. Perfect. So you know that each of those plasters will have like a different proportion, right? On the water and the amount of powder that they have. For you, it's really easy because you have like those kind of predetermined amount of powder that you're going to have. So you just need to follow the instructions and place the amount of water that they require. Okay. But if you want to save money, for example, on practice, you can buy like pounds of the cast, okay, of the powder. But the drawback of that, from that approach, is that you need to have some sort of scale so you can see how much powder you're taking. Okay? So you can make like a 3 rule for those who like math, okay? And defines like the ratio that you have for each of the stones that you're going to use. Okay? What's important, if you place too much water, it's going to take longer, okay, to set. If you use hot water, for example, it will set a little bit faster. If you use too much water, again, that will expand more than usual, okay? So remember that every single stone that you use will expand, okay, more or less depending on the composition that they have. And that's called hygroscopic expansion, okay? Whatever. If hot water is used, you're going to make it faster. The same with alginates, for example. I think on the day that you took the impressions were a little bit warm, right, inside the lab. I don't remember if it was with your class or with the D2. It was setting really fast. But if you use cold water, you're going to retard the setting time, and that's fine as well. What happens with these stones? Of course, they are super hydrophilic, okay? Meaning that if you leave like underwater, or again, if you just have too much water, that you expand even more. Okay? Every time that you're putting the cast, I don't know if you realize that, but usually the stone that you're using here takes about 20 minutes, right? For you to remove from the impression that you had. Okay. Did anybody realize that at some point the stone was really warm? Yes. Okay. So that's an exothermic reaction. Okay. So every stone will go through an exothermic reaction, and just remove the cast after it went back to the room temperature. Okay. Because during the time that the material is really warm, you have like kind of crystallization process, and if you try to remove that earlier, that is going to happen like a lot of breaks, okay? You're going to break your teeth, you're going to lose probably your impression, you're going to lose your cast as well. Okay? So wait until it goes back to the room temperature. This is more like a curiosity, okay? I don't think that we had that in here, at least I never saw. But there are some manufacturers that, in order to try to get a little bit better mechanical properties, they created some sort of solution with colloidal silica, okay? And that makes the properties of the stone a little bit better. But again, just use water and it will be fine as well, okay? It's just a curiosity, but if somebody asks for that, you know that there are some manufacturers that created like a specific material to substitute the regular water that you have, okay? So setting time, basically we spotlight for about 45 to 90 seconds, usually actually go for less than 1 minute, okay? Anything below 1 minute it's fine. If you're going to use mechanical spotulation, that's a little bit less, okay? So you just, I have a video of that, but you just like start to mix the powder with the liquid, and after that you place on the vacuum machine, and from there everything's like mechanical. The initial setting time, that's basically the time that we have from the time that you start to spotlight the material until the time that you can really pour the impression. You range from 2 to 5 minutes. If you place like too much water, that will be a little bit longer. If you place little water, it will be a little bit less, okay? The final setting time, usually 5 to 30 minutes. That the ones that you have in here range from about 15 to 20, okay? There are some other that are faster setting, and what changed basically is the accelerators that the manufacturer placed inside the composition. That's what makes the material faster. But again, that's the important information, okay? Every material go through an exothermic reaction, okay, and just remove the cast after it went back to the room temperature. Usually, just leave there, go for a coffee, come back, and that will be fine. So the manipulation, as you saw before, is really straightforward, right? You have the liquid, place the powder over there, mix everything, make a nice mass. If you're using for the mechanical ones, we had some in the lab, although I never seen anybody use it. Basically you adapt like the dough that you did like on this part in here, and you adapt on the machine, and this creates kind of a vacuum, and it's like a rotary instrument in here that manipulates everything, and it gets a very, very nice result. Okay? I didn't really need to show you that. Do you want to see the video or not really? I mean, you did that in real time. This is really straightforward, right? Exactly what you did last time. So you have the water, place the powder. At the time that you are manipulating the material, the stone is a lot easier to manipulate than alginate, right? What do you thought about the alginate? It's easy to mix or not so easy? It's easy to mix? Okay, perfect. Okay, I saw some people, okay. So it's not so easy. So that's the vacuum that you have, okay? So you manipulate the way that you did so far. This is the mechanical one. So we started the same way. After that, we place on the machine, and the machine will do everything for you. By the time that you pour the cast, always use the vibrator, okay? And always exactly the same as you did, right? Now, actually, if you hit like a table with your impression, that will work as well. Yeah. But this is kind of easier. But tends to be messier, especially when you're starting, because it tends to pour exactly like this. Okay, so the trick when you're putting the cast is always to start from one side, always from the same side. Why? Because if you start like one from the left, one from the right, when they get to the center, you have an air balloon. Okay? So always do a single movement. So always insert your material from one side to the other side. Okay? In fact, you can see a bubble here, but after that, that will get out. Okay? So what's the problem with the vibrator is that usually you do like a mass over the vibrator. So always place like a paper or plastic or something. It's similar to the box that you have, right? So it's the same idea. They place upside down. So the only problem with placing upside down like that is that the air tends to go up, meaning that if you have a lot of air bubbles, air trapped in your dough, what's going to happen? That is going to be on the occlusal, okay? So if mechanical spatulation is really unlikely to happen, if you can spatulate really well manually, that's unlikely to happen. If you mix like, if you're really lazy mixing that and it's not like a nice mixture, it tends to get a little bit worse, okay? That's why all the time you do the box wax and place that facing down, okay? But that's the only explanation, but the answer is that both works, okay? For me it's really funny because people ask me, oh, do you like to box like your impressions? And my answer is, okay, I never poured an impression after I moved here because you do that, right? And the second reason is just because I sent everything to the lab when I need to. Back in Brazil, I think I never did that either. So usually I just place a lot of my stone on over the table and flip upside down the same way that they did. Okay. After a while, the material will be kind of hard, so you can just grab a knife and kind of make that squared as well. So that's the lazy way to do the same thing that you do. Okay. Any questions so far? No? Okay. So what I was mentioning is that you can add some things on the water that you use to mix the cast to make the setting reaction a little bit faster, okay? You don't need exactly to know which ones are those, okay? But it's just important for you to know that you can add some things to make the setting reaction faster or slower, okay? Usually the cheapest way and the easiest way to do it, take like an old stone cast, you can kind of trim that a little bit so you create a powder, right? So by the time that you're mixing your stone, you add that powder from the previous cast over there, okay? So that will make the setting reaction a lot faster, okay? The problem is that you're going to have a little bit more expansion, you're going to lose some properties, but when you just need like a quick cast for diagnostic purpose, that works well, okay? But if that's your final cast for to send to a lab or to send for a final product, like a final crown, that's not exactly a good idea, okay? Makes sense? Yes, no, maybe? So basically the accelerators will make it faster, the retarders of course will make it slower, okay? So what's the problem with placing too much water? It's basically this. Every time that we mix the powder with the liquid deeply, we are going to start to have some formation of crystals. Okay? What's the problem? Those crystals usually are going to absorb the water. Okay? What happens if there is too much water? The crystals are formed, but you still have a lot of water around, meaning that they grow a little bit more than they should. Okay? And besides the point that will take a little bit longer for them to set. The second problem is that you're going to have a lot more expansion. That basically is everything that we discussed. And there is no stone that's indicated for every case. You need to know where you want to get. And the indication will depend, again, on what you want to get. Any question about the casts?
What was the first problem? Adding too much water?
So you have to expand a lot more, and it'll take longer to set.
Isn't that every stone would go some type of expansion? It started with hydrogen.
Starts with what?
In Asia, something scopic expansion.
Yeah, hygroscopic expansion. It's just the proper term for that. It's just an expansion. But for example, if they ask that on boards, probably they are placing hygroscopic expansion, but that's just the proper term. But we have the name expansion somewhere. Okay? So that's the most important information. Okay, any other question, guys? No? Okay. So now let's try to make you understand why you do this, right? Do you miss that part? You're still doing that, but do you enjoy it? Yes, some of you do, some of you don't. That's fine. So let's try to explain why you do that. Okay, that's kind of would not say exactly old technique, but it's a technique that can be used a lot, okay, and works well. So those slides shows basically how you get from this wax up all the way to your final product. Okay, so now we're trying to understand like the lead part. So what happens? Okay, this is a lecture about investments. Okay, not financial investments, but investments that you use in dentistry. Okay, there are basically this material in here. Okay, that can be based actually in the stones. Okay, and they are similar to the stones, to be honest. You mix like a powder with a liquid. But what's the difference? We're not trying to take an impression of anything. You're just trying to create the format for your final crown. Okay. So what's going to happen? You're going to have your wax up, okay? That wax up will be placed on an investment like this, and will be placed on an oven, and after that you're going to inject either like, our lab technician is going to inject either like a ceramic or a metal over there, okay? So that's how you get like a final crown, okay? We're going to discuss step by step. So what's the idea? It's basically based on the gypsum that we had before, or phosphate, okay? Again, that's not exactly the important part. We can have also a refractory material that's basically silica, okay, silicon oxide. That's not a big deal either. So what's the important information about the investment? It needs to resist the heat of the burnout of the wax that you place inside them and the casting process, okay? That means that you're going to have 3 different materials for that. One that's suitable for gold, one that's suitable for metal, and one that's suitable for ceramics, okay? Because all those materials has different melting points, meaning that we need to heat them in different temperatures, okay? So the gypsum one is the weakest one, basically, so it's just suitable for gold, that has like a lower melting range. And the phosphate bonded is usually using to melt metal alloys, and the silica bonded is the highest temperature, is just using for higher melting alloys or ceramics, okay? So both works. So what's the problem? Remember that we discussed on the first lecture that every single material, when they are heated, they will expand a little bit. Remember that? And when you cool them down, it will shrink a little bit. So here's the same idea, okay? What's the problem? How do we control how much our alloy, our metal, is expanding or shrinking? It's a little bit hard to control that. But studying that, we know that will range from 1 to 2.5%, okay? So we need to compensate that somehow. One of the ways that we can compensate is to use that type 5 stone, remember, that expands a little bit more, right? Or the other way to start to compensate is to use an investment that can also expand, okay? So part of that expansion will come the same way as the stone from the hygroscopic expansion, and part of that when those materials are heated, okay? That comes from the thermal expansion. So that's basically the same idea, okay? That's the same explanation, you can read later. So what happens? You have different sorts of wax-ups in here, okay? So you have inlays, onlays, you have basically a copy for a crown, you have like frameworks for a bridge later. So what do we need to do? We need to take that wax-up that's pretty much the same that you did. Okay, you can do that in wax or acrylic resin that's similar to the ortho resin that you use. And we add like a sprue, okay? So that part that you created on the Dr. J's course would be called like a wax pattern, okay? Because it's the final result that you want to get. So you connect those wax patterns or acrylic patterns to some sort of, it seems like is a straw, the one that you use to drink water, for example, straw, right? So it looks like a straw, okay? Let's call it a sprue. For some reason, somebody created that name, okay? So you connect both, and you place that in a kind of area that's a little bit bigger. So after that, we pour our investment, okay? Oh, sorry, I forgot to say. Sometimes they have like kind of chamber like that, okay? Because since the metal is going to lose temperature really quick, If you don't add the amount of material that we need, you're going to have failures, okay, by the time that you inject either like the metal or the ceramic. So you have like some reservoirs like that, or like some chambers to have a little bit of excess of material. So if the ceramic or the metal shrinks, that will kind of create a pressure to bring more material from that chamber, okay? So that's kind of a safety measure that you can have, especially when you're doing like a big wax pattern like that, like a framework, okay? You're going to find on some books that's called a runner bar, but all the time will be some sort of reservoir, okay, the French word. Okay, anyhow, so you need to have both connected, okay? And after that, you are putting like the investment, okay? So it's the same idea. You're going to have a ring. That's basically our box, okay, that you created to create like your casts, and you're placing the investments inside it, okay? So here you can see like the screw or the reservoir with the wax pattern that you have. So we mix the investment, we pour inside that ring, okay? It's very important that we don't have any bubbles, especially around the wax pattern, okay? Otherwise you're going to create like a kind of positive effect. So for example, if you have a crown, you're going to create an additional form that should not be there. So it needs to be completely absent of any voids. So we basically block this. So after that, what we do? We need to remove the wax from there, okay? The wax or the resin. So we place that on an oven, and that oven will melt all the wax that's inside. So having here, for example, the wax pattern, okay? After you place on the oven, that wax will evaporate. This material is very porous, similar to the stone that you have. And you're going to have like an empty space, okay, for the ceramic or for the metal to be injected, okay? Seems like an eagle, right? No, just fine. That's fine. That's okay. The important information again is an empty space, okay? So from that empty space, you're going to either inject a metal or a ceramic, okay? So to inject the metal, have you ever figured out that on the lab upstairs you have some like sinks that are really rounded, like and big? Yes, they used to have something similar to this, okay? There's a centrifuge, okay? That you do like that manually, basically. For some reason, they removed from there. I don't know how long ago was that, but of course they use that to inject the metal, okay? So basically what you do, you melt the metal over there, so you have like a big like fire, you elevate the temperature a lot, and you have like a centrifuge that you basically just spin for a few seconds, and the metal will be injected on that empty space where the wax is right now. Okay? Make sense so far? Perfect.
Quick question.
Go ahead.
So for the screw, is the screw wax as well, or is it like a straw and hollow so the wax?
It can be both. It can be both.
Does it stay in there after long enough?
Not really. We stay there, it will melt as well. So it will be, at the end of the day, the screw is in here, it will be an empty space, so that will create some sort of channel for the material to get in.
Okay.
So that's why it's important to have, because you need to have the space for your metal or for your alloy or for your ceramic to be around here, but you need to have a pathway all the way up to your wax pattern, okay? So that's basically what the screw creates. Okay?
What about chambers? The chamber has like a wax inside also, or?
Yes. So all the time, you need to think like that. If you just have something that's hollow, okay, the investment will get in, right? It's important that by the time that it melts, it really have like an empty space, okay? Usually something that's kind of prefabricated. So you have like something in wax, but it's prefabricated that shape. So your work is basically just to connect with the wax pattern that you have. Okay. After that, you inject the metal, and of course, you have your metal injected or your ceramic injected, and you're going to have a lot of the investment around it. So by the time that you remove, you have this kind of thing. So it's like kind of a dirt surface, okay? And that's not like super well defined, just because again, the material is porous, okay? So if it's a nice injection, will be completely, again, absent of any voids, but will be kind of a rough surface. So after that, what the technician does, he adjusts everything. Look at the screw in here, okay, so in the end, all the time you're going to have like a connection with the external surface that the technician needs to remove it, needs to polish the entire surface and adjust all the occlusions based on the cast that you send to them before they send back to the clinic, okay? So after the vesting, the restoration is to be adjusted and polished, and until it gets to a shiny surface like this, okay? So that's basically the final product that you get, okay? So as you can see, the lab has a lot of work. Now it's easier, of course, because you have CAD/CAM machines that basically everything is done digitally, okay? But even with the CAD/CAM machines, we still have something that's similar to a sprue. That's what connects, like the blocks that we have, or the discs that we have, ceramic or metal, with the final product. So the technician still needs to cut that sprue, okay, out. We're going to have another lectures at some point about it, and need to adjust the occlusion again, okay? But that's the general idea. If they inject in ceramic, it will be exactly the same idea, okay? But they need to polish, they need to crystallize the ceramic sometimes. They need to adjust, they need to polish, and they need to glaze the ceramic until you get to those final results, like in here, okay? All the time the process is the same, so you're going to see in the future that this is called a heat-pressed technique, okay? So for a lot of ceramics, we have a CAD/CAM technique or a digital technique, and the other way is the heat-pressed one, that's this one, okay? That you're going to heat the material, and you kind of press or inject them inside that space that we used to have. Okay? So this, for those of you who doesn't know Russian, I will try to translate that, okay? This is just the best video that I found, so that's okay. So this is a fancy way to place the investment. So the same idea, we had the wax pot. It's going to mix that, place on the vacuum machine to prevent trapping any air bubbles. A lot of people, a lot of technicians does that with like a painting brush in order to make sure that you don't have bubbles inside the restorations. After that, you're putting everything, okay, wait it to set. So this is for injection of ceramic, okay. This is slightly different, the materials that we use. So that's basically the investment that we have with the space there to place the ceramic. Place on the oven that will evaporate that wax pattern that he has. These are ceramic blocks, okay, that he's placing inside. This is a ceramic oven that you create a lot of pressure to. We will melt the ceramic and we will inject that, okay, in a similar way as the centrifuge. So what happens inside that is basically this. So you have the empty space. When the ceramic melts and is injected over pressure, it's getting like to the space that was empty before. So after that, the technician needs to cut, to find the ceramics inside that investment, to clean the entire surface. The sprue will be there, so we need to cut the sprue. Okay, there are some liquids that help with the process, so cutting the sprue. After that, he's going back to the cast, he's going to adjust everything, clean everything again, painting the surface, glazing the surface, and until you get to the final restoration, okay? So as you can see, it's really like a lot of work, okay? So it's really nice. It's really nice if one day, by the time that you start to work with your lab technicians, you can visit them. I personally learned a lot from having like kind of a closer relationship with some technicians. Because sometimes you do the prep, you think, well, that's a really good prep, you send the impression to the technician, he can do the work. Okay, that's perfect. Okay, in fact, the technician usually can do the work. But sometimes they come with some sort of tweaks. Okay, especially like when you have like minimum thickness preps, for example, laminate veneers. A lot of times my technicians came back, hey, the prep is really nice, but next time take a look on this corner in here, maybe you can try to make it more rounded, and some things that I was not aware before, but the technician trying to do like the final ceramic for me, since for her was a little bit more complicated, she came with some advice for me, and that was really nice. It was a good learning experience. It's really nice to have like a closer relationship when you find the proper technician to work with, okay? I try to work with probably 5 or 6 technicians, so it took me a few years until I find one that I like to work with, okay? But after you find that person, just try to have like a nice relationship with her, or with the technician, sorry. And that was a professional relationship. Okay.
So, what's better? Is it asking better?
Both works as well. No, both are exactly the same ceramic. So if you can, so this is a good question, okay guys? He asked me if what's better for a ceramic, for example, if it's a milling process, okay, a catch-can-based ceramic or a heat-pressed ceramic, right? That was the question. Both are exactly the same ceramic with exactly the same properties, okay? What happens is that with milling, you are removing basically the human component. So if there is any like mistakes by the time that you are injecting the ceramic, that will never happen on milling. But if you get a skilled lab technician, the outcomes will be exactly the same. Okay. I did our research back in Brazil with exactly trying to address that question. The results are exactly the same. The results on the literature showing the same, especially like regarding marginal adaptation. They're exactly the same. Okay. So if you get a correct technician, that will not work well. But with a good one, it's pretty much the same. Okay. The last part of this lab, sorry.
That's okay. When you're taking it out of the investment, how likely is it to like damage the actual plant itself?
Really good question. Again, for a good technician, they usually will never do that. When I did that research, we did I think 50 veneers. I lost about 4 or 5. But I had no clue how to do it, so the technician said, hey, just cut and try to clean everything. I said, okay. So 2 times I think I cut the investment, I cut the ceramic with that. So I didn't know. So it's kind of a learning curve as well. It's not hard, but when you work with a minimum thickness like 0.4, 0.5, when you touch like the ceramic of a burr, sometimes it kind of breaks a little bit. So that's the hard part. But a good technician, the technician that I used to work, she used to inject the ceramics with 0.5 millimeters, and she could reduce like up to like 0.2 or 0.3. So if you try to do that on milling machine, that will usually break. So all the time that you see like veneers with less than 0.4 millimeters of thickness, usually that was manually finished. So it mills a little bit like thicker, and after that the technician goes with some sort of stone or some sort of rubber and polishes back up to like 0.2 or 0.3. Okay, but that's very, very thin.
I was just thinking about polishing it.
Okay.
How much risk is there when you're dealing with a cleaning like that, which point when you're coming in with a ceramic polishing?
It can break, but again, you need to be a skilled technician to do it. That's why I don't see so many cases like that. Okay, it's hard. And in fact, we had like one technician from Ivoclar a few years ago, back in Brazil as well. And it was a case with 10 veneers, he broke one of them. I was trying to polish and say, okay, they just start over. So he redid it. And that can happen, so that's fine. Okay. That's the benefits about milling. If you break something that you just mill it, you just hit enter again. That will mill again, you can start over. So it's easier sometimes, it's less time consuming, but both gets nice. Any questions? No? Okay. So the last part of this part of the lecture at least was about the wax. Okay? You love waxing, right? I know. So this is also wax up, okay? So we have like some waxes that are a little bit more translucent. So you can get like really nice results from that. But anyhow, what's a wax? Basically you have wax based on minerals, plants, or animals, okay? And you're going to have like synthetic wax that comes from other subproducts, okay? That are pretty much the ones that you use here. So basically what are the properties? I'm telling you the obvious because you already know that. It has like a melting range, okay? Because you need to warm up, right? The wax before you try to wax up something, or you try to do your base plates, indentures, or RPGs. every wax, again, since you're melting them, you go through some sort of thermal expansion, so in the end it will be bigger than, a little bit bigger than you expect, okay? But the higher the coefficient of thermal expansion, more expansion the wax is going to undergo when it's heated, okay? Again, that's obvious. But every time that you created like a lot of heat, and after that you wait the material to cool down, especially if you try to blow some air on that to make it faster, okay? I know that you do that because I did that a lot too, okay? That's fine, doesn't matter. But you're going to create some residual stress. So what happens sometimes when you get like a bad technician is that on the wax, he creates some defects on the wax. So by the time that they inject that, the snap is not as nice, okay? It's not so homogeneous, okay? That's one of the problems that you can have. But again, with a good technician, that will never happen. And in fact, when the technicians work with laminate veneers, a lot of times they use like a layer of acrylic resin because that's a little bit easier to work and it's more resistant. Because think about, if you try to remove the wax from there, okay, you try to remove the bisacryl, right? The integrity sometimes from your preps, and what happens sometimes? Some of you broke that, right? Imagine like a veneer that you place like 0.5 millimeters of wax. It's basically pretty much impossible, right, to remove. So usually you make like kind of a bed of like a core of acrylic resin. So that's hard and that's more resistance, and you apply the wax over it. Okay? That's another way to do the same thing. So again, this is the obvious part. You have several waxes that are different from each other. And they are divided basically in pattern resin. That's the one that you use to cast, to make inlays, onlays, crowns. You have the processing wax. That's the one that you can manipulate basically without any heat. That's the boxing wax, the utility wax. It's just like kind of a sticky wax. And the impression one, that just to take bite registrations, that usually, again, you don't use in here. I think you use it at some of the cars, like a bite, like kind of a wax plate that you bite over it. Yeah. So you didn't do the bite registration for Regisil yet, did you? Yes? I know that somebody tried to take an impression of the Regisil. That was fun. They said really fast, so no time for that. Anyhow, those are the ideas, okay? So those are the pattern resins that you have. So it's not a big deal. Those are the processing wax that you have. So you use all of those. And those are like the impressions wax that you can have. So it's basically the same idea. The patient just bite. You can melt a little bit the surface if you want. That's ideal when you have, you just want to mount the cast for diagnostic purpose. It's not your final product, okay, that's coming from there. So you can do that in wax, okay. For a final restoration, that's not ideal because the wax will not capture all the details. So by the time that you try to place your cast there, will never go to the same position, okay? That's why the Regisil in a certain way is a little bit better, okay? Or just sometimes hand articulate when the patient has all the tooth, except one. That's basically the new guidelines that you have in here, okay? Because if you don't do the bite registration a proper way, you're shifting the entire occlusion of the patient, and in the end of the day, by the time that you try to cement your final crown, for example, you need to do a lot of adjustments, okay? So, you start the alginate lecture for like 5 minutes. After that, you have. But there's a really nice beach. Actually, that's one of the most beautiful ones that I've ever been. So that's in Portugal, in the south of Portugal. It's called Dona Ana Beach. It's really nice. And there's a problem with the accent, right? About beach and pH. And that was one of the first things that somebody told me. Like, okay, when you want to talk beach like that place, you just need to give a smile, and the other one you need to open your mouth. So. But for me, it sounds the same. Anyhow. Yeah, time for silly jokes. So you got all the points that how you get like your cast done, you know why you do the wax up now. So are you a little bit more happy, a little bit happier about why you do the wax up now? A little bit.
When you're doing them, what's the difference in that process? You do
can explain later, but we're going to have a lecture about it and almost 2 years from now. So we know everything so far, why you did that, what the lab does, okay? So let's start to talk about the impression materials that you can use to send all our work to the lab, okay? So we have different impression materials, but again, the goals are always the same. Try to copy whatever your patient has in their mouth, okay, and send that to the lab. So it's kind of a tooth or a big class 4 restoration. You can prep that for a crown. There are different approaches, but that was a crown. So you take like a nice impression. This is PVS, that's the material that we use the most here, and you have like a final crown like that, okay? So we know all those processes. So let's just focus a little bit more on the impression part, okay? We're not exactly talking about technique, but we're talking about the materials that you can use for that. Okay? So what's important? To have a good impression, so by the time that our technician receives the impression per the cast, he or she can see the entire margin, okay, of every preparation that we have, all details of every single anatomy that the patient has on his or her mouth, okay? So for that we use a tray, that's obvious for you now. Use the impression material, that's obvious for you now as well. So we have an impression, that's the negative information about the mouth of the patient, and we put the cast, that's the positive information, right? So impression is the negative copy, and the cast is the positive copy of whatever the patient has in his mouth, his or her mouth. And for that, again, what's the characteristic that I mentioned that you can have for every single material in dentistry? Perfect. So it needs to be biocompatible. It needs to be cheap, easy to mix, needs to be compatible with whatever you're using to pour the cast, right? It needs to recover from strain, so every time that you place in the mouth, remember from that chart that you create stress. By the time that you remove, you decrease stress, and the material tends to go back to the initial position, initial form. Here is exactly the same idea, okay? PVS is the best of them. We have some other materials that works well as well. Okay, so not wasting a lot of time on this. But basically the same idea, okay? By the time that you remove the material from the mouth of the patient, it should not tear. Otherwise, you're going to lose the information that we want to copy. So pretty much those ideas, okay? Okay, so what's the first material that we have? The wax. That's the biting wax. Okay? So you have like a bunch of wax, the patient bites on that, and you create the interocclusal registration. Actually, the first denture was made based on impressions made in wax. Okay? So you can imagine that that's not exactly an easy task, right? And probably the patient was burned a few times. Okay? If you burn your finger trying to wax up, imagine somebody trying to take an impression of the entire mouth. So probably it's not the most comfortable situation. Yeah. So that was the first like wax impression, and that was the first time that somebody decides to use like a metal tray to do it. Okay? So it was just information. So that's one of the first dentures that they had. Okay? As you can see, why do you think that they have a kind of a spring in here, and the lower and the upper at the same time? Because the impression materials were super bad, and of course there was no retention, right? Because didn't have suction, didn't have the border molding that you're going to learn with Dr. Love. His lovely class. So that one I thought about ahead of time. Okay. Okay. So you have a spring basically to make all the time a pressure against the lower and the upper, so the patient will all the time trying to bite down. I have like something forcing like his mouth to open again. But the benefits of that, probably the natures were really stable, right? They'll never fall down. Just, I was the only one, but okay, I'm not trying to explain. You got the point, right? Always trying to open. It's just funny for me, but that's fine. Because the evolution, everything that's in red is like a hard material, okay? It's a non-elastic material. Everything that's in green has some elasticity over there. So the ones that we had first were the wax, the stones and the compound. Did you use the compound already? We call that Godiva in Brazil. See? But of course not so tasteful as the real Godiva. But then the compounds, those like green sticks that probably you have somewhere in your material, don't you? That if you ask the D2s and D3s, they love to use that because of the border molding on RPG and full ligatures. Okay? You can ask them, they really, really love it. I'm joking, they really hate that. But, it's a material that works well as a green stick. Okay, I have a picture somewhere. The zinc ionic paste that works really well, but we don't have at case. I don't know if we have in US, but they exist, so you need to know at least that they were there at some point. Reversible hydrocolloid, they were really popular before the Second World War. After the Second World War, they produced the alginates, and from there, all the elastomers that we currently have in the market. Okay, there's a historic explanation why there was like a huge push towards like from 1940 up to like 1970, okay, until they create the elastomers, but we're going to get there part of it. The material that's most used one by far is the PVS, okay. There's polyether that's very used as well, so those are by far the most popular ones. Alginate is always used a lot. Probably this chart is a little bit different because a lot of dentists now does like digital impression, okay. But it's still, currently we still need to do some impressions for some kinds of clinical cases, okay? Because the digital impressions that we have still doesn't solve all the problems, okay? Okay, do you want to access the quiz? So you can see if we have any questions that I didn't address. I guess that on quiz number 2, that's about Dr. Asaf's lecture, we're going to have a few things that we didn't go through, okay? But on that case, I will give you the answer and we go from there, okay?